This is a second part of the lecture on classical conditioning. So I wanted to just sum up some ideas with classical conditioning in terms of timing. And timing does matter. There are 4 different ways that you can try to pair the conditioned stimulus and the unconditioned stimulus, and some are better than others. With delayed conditioning, you present the conditioned stimulus while the conditioned stimulus is still there. You present the unconditioned stimulus. So you have a bell, and then while you're ringing the bell, then you present the unconditioned stimulus. This presents the best situation for conditioning, especially if the time delay between the conditioned stimulus and the unconditioned stimulus is short. With trace conditioning, you present the conditioned stimulus, you take a short break, and then you present the unconditioned stimulus. So you have the bell, you have a pause, and then you have the unconditioned stimulus. So the conditioned stimulus precedes the unconditioned stimulus, but they do not overlap. And the longer the time delay between the conditioned stimulus and the unconditioned stimulus, the more difficult the conditioning is. So it's best if there's a short delay between the two. A third type is simultaneous conditioning, and this is when the conditioned stimulus and the unconditioned stimulus are presented at the same time, and this results in very poor conditioning because the conditioned stimulus, in this case the bell, doesn't predict the unconditioned stimulus in this situation at all because they happen simultaneously. The last one is backward conditioning, and this is when the unconditioned stimulus is presented and then the conditioned stimulus is presented, and this results in little or no conditioning. Because again, the conditioned stimulus does not predict the unconditioned stimulus. Now, sometimes after extinction has occurred in this type of conditioning, spontaneous recovery can also occur. And spontaneous recovery is when the conditioned response still randomly appears sometimes after the conditioned stimulus is presented. So this, in our case of our classroom examples with Connor Malloy and Emily Miernick, if suddenly someone walked up to them out of the blue and said, "Can you go get something for me?" the word "can" might make them flinch out of the blue. Now you also have a situation with generalization and discrimination. So with generalization, this is when something is so similar to the conditioned stimulus that you get a conditioned response. So you have the same reaction to similar things. So in this case, Michael Jackson, his sister, and I think this is funny, Gollum. But in this case, there's also discrimination. And this is when something is so different to the conditioned stimulus that you don't get a conditioned response. So again, Michael Jackson with this finger gesture. Mr. T looks nothing like him. Dora the Explorer. So if you have multiple things that look similar, they might get a conditioned response. But if you have different things that are not similar to the conditioned stimulus, you are able to discriminate the difference. So if you remember in our experiment, the subjects of our experiment, when they heard words in the beginning that ended with "an," they might flinch a little bit until they discovered that it was the word "can" that was actually the true conditioned stimulus. And so eventually what they were able to discriminate between the word "can" and "pan" and things like that. Now, classical conditioning in humans is an interesting experiment. So basically you had John Watson, and John Watson brought classical conditioning to psychology with his famous Baby Albert experiment. And it's also known as aversive conditioning. And so I'm going to have you go to the YouTube link in your class folder so you can watch the experiment with Baby Albert. And what you'll see is this study would no longer be conducted today because it would be considered unethical because it causes distress to the baby. But this is how John Watson was able to demonstrate that classical conditioning can be done with humans. We also have what's known as first order and second order conditioning. And first order conditioning is basically what we've been talking about this whole time with classical conditioning. Bell plus the meat equals salivation. So a neutral stimulus becomes paired with a unconditioned stimulus. That neutral stimulus becomes a conditioned stimulus and eventually evokes what at first was an unconditioned response, but now becomes a conditioned response. Now, second order conditioning is when you basically add another neutral stimulus and you pair it with the conditioned stimulus. This happens after first order conditioning. So you add a light, you pair it to the bell, and then you get salivation. And then eventually the light itself will skip the bell and will bring about salivation. So in second order, which is also called higher order conditioning, a new neutral stimulus can sometimes become a new conditioned stimulus, and all that is required is for it to become associated with a previously conditioned stimulus. Now, it tends to be weaker than first order conditioning, but it can be done. Now, conditioning also is associated with taste aversions. And basically what you had a scientist by the name of John Garcia. And he discovered that when food becomes paired with sickness, the conditioning is incredibly strong, even when the food and the sickness occur hours apart. So you eat something in the morning and then later in the afternoon you get a stomach bug and you throw up. Whatever you ate in the morning, you will develop a very strong taste aversion to, and it will be paired with sickness, even though chances are that food had nothing to do with the illness. The one thing is the food has to be noticeable, okay? It has to be salient, something that you recognize. Basically, we think the more ecologically relevant the conditioned stimulus is, the stronger the conditioning. So food's really important for survival. And so basically what John Garcia noticed was that humans seem biologically prepared to learn some associations rather than others. And organisms are predisposed to learn associations that help them adapt. Now please go to the next videotaping to see the presentation on the Garcia and Kohling study and most of the rest of this unit's slides.